Hello students. Today we are going to continue the same exercises that we have already been seeing. So we have been doing the numericals based on the concept of impulse and law of conservation of momentum. So if you turn to page number 259, so 259 page number, and then if you see the questions which is down, so based on impulse and law of conservation of momentum, we have already done 16, 17, 18, 19 we have finished, and also we have finished the initial four questions in this page. 20, 21, 22 and 23 we have already done. So we're going to start with question number 24. Remember, these questions are very, very important, and also whenever you read a question, please write the parameters and then start drawing a diagram. So right now also you can pause the video and make an attempt to imagine the situation first of all. So read the question carefully, draw a diagram. After you draw the diagram imagining the situation, immediately you can write the parameters which is given. So let me start reading for you. Maybe you can do this one, pausing this video and then do it yourself, and now as I continue now, you can see whether whatever you have thought about it is correct or not. A child suspends a steel disc in a vertical plane by a means of a thread. Then he shoots bullet on the disc by a toy gun. If the mass of each bullet be 2 grams and the bullet striking the disc with a velocity of 11 meters per second is returning with the same velocity, then the average force is being exerted. Then what average force is being exerted on the disc? It's a question mark. The child is firing 3 bullets per second. Now look at the image in the situation now. There is a straight disc which is here, right? So a ceiling maybe, and then a disc is being suspended by a thread. Now as this disc is being suspended by a thread, now a child is taking a toy gun, right? And then and the child is trying to fire small bullets. So tiny bullets are going up and firing. The child is firing, and then this bullet, it will just hit this one and then it will come back. So as these bullets are going, it goes in 11 meters per second and hits it one and then comes back and again 11 meters per second. Now when it is constantly firing 3 bullets per second, look at this one, 3 bullets per second, continuously bullets are going up and hitting this plate. What will happen? There will be a force will be exerted in the top. So you will get a force which is exerted in the top here. It is asked what is the average force which is being exerted on the plate. That's what it is asked here. So because you are constantly firing bullet. It is quite a nice question to think and ponder upon. Let me take it out as the following parameters. Mass of the bullet 2 grams, it is already given here, and initial velocity of the bullet is 11 meters per second because it is going and hitting in 11 meters per second ratio, and final velocity after rebounding, after bouncing back, it comes back also in 11 meters per second. So number of bullets is it is in 1 second. Now 3 bullets in 1 second is a rate of the bullet in which it's coming out. Similarly, we have done one more question in this same variety we have done. So you should be able to take out that also and see once, right? So it is important to relate what are the similar questions it is there. Look at this one. Question number 16. A machine gun, 5 kg, 30 bullets each, fires 30 bullets each of this much of mass per minute. Now look at them. 30 bullets are coming per minute. And we are asked to find out the force exerted to keep the machine gun in position. So if you look at the 16th question, how it is done, the similar way this question also should be done. So turn to your page, see the 16th question now, see how it is done, 30 bullets per minute, how it was done, and you are asked to find out the force. Similar situation is there, exactly quite a similar situation is there. Now we need to find out the force exerted. So now we'll start the answers now, how it will be there. So first thing is impulse. Formula, what is impulse formula? it is equal to change in momentum. That's what impulse is. Now what is impulse? Force into time is equal to change in momentum. So it is asked, average force is asked, then you can do the change in momentum. Now first of all, you need to find out change in momentum for one bullet. Just one bullet to go and hit. What happens of the change in momentum? So what a change in momentum means? Mass into final velocity minus initial velocity. So that's what change in momentum is. Look at this scenario. Now mass into, what is the mass? 2 grams, and then final momentum is initial momentum. So it is going to be 11 minus of minus 11. Why it is minus 11? Because it is coming back. So you get here minus of minus 11. What is mass? 2 grams. It is 2 into 10 to the power of minus 3 into these two things. It will become 11 plus it will become 11. It will become 22. So it is going to be 44 into 10 to the power of minus 3 kg meter per second. That is change in momentum for one bullet. Now how many bullets are going? Number of bullets are 3 bullets. So what is the next scenario we will be taking? The next scenario is change in momentum of 3 bullets, or you can say due to 3 bullets. So it's going to be equal to 3 into 44 into 10 to the power of minus 3 kg meter per second. Right? So what's the answer here? The answer is going to be these two things is going to be 132 into 10 to the power of minus 3 kg meter per second. If you want to shift this decimal point, 0.132 also you can say kg meter per second. Now what the question is asked? You need to find out the force which is exerted. The force which is exerted is going to be equal to, this is going to be equal to F into T. Force into time. So what is the time here? Time is going to be equal to 1 second. In 1 second, 3 bullets are coming out. So what is the force? If suppose 1 minute is given, 3 bullets are coming out in 1 minute, then time is going to be equal to 60 seconds, 1 minute. So force is going to be equal to, since time is equal to 1 second, it is 0.132 divided by time is equal to 0.132 itself, newtons. Now we'll see whether the question is answered as right. Yes, the answer is given here as 0.132 newtons. That's the right answer. Alright, we'll go to the next question now. Question number 25. The next question is question number 25. A shell of mass 0.02 kilograms is fired by a gun of mass 100 kg. The muzzle speed of the shell is 80 meter per second. Find the recoil of the gun, recoil speed of the gun. It's a very, very simple question. You can draw yourself and find out. Pass this one. Try to draw the diagram for this. Just pass it. Take some time. Draw the diagram and write the parameters. So there is a gun. This gun mass is 100 kg. Quite a heavy one. 100 kg is a very big gun. And this one, this is the bullet which is going. That is called muzzle speed. The velocity is small v. It is going to be equal to 80 meter per second. And this is a small mass. M is equal to 0.02 meter per second. Sorry, kilograms. Kilograms is given here. So this bullet is going here. As soon as it gets released, you will find this one is going behind because there is a equal and opposite force it will be exerting here. It will goes in a velocity v. It is asked, what is this v? V is question mark because the v muzzle speed is there. So how will you know? According to law of conservation of what? Momentum. So m into small v plus capital M into capital V is equal to 0. What is m into small v? This is for the bullet. And what is this one? This is for the gun. It's a very simple question. You should be able to do this one very easily. So substitute this value here, substitute this value, and substitute this 100. V you can find out. Take it to the next side and you'll be able to find out the value of V. V you can easily find out using calculations. So all the parameters are given. Please find out the value of V. Okay. But remember, you should be able to try doing it without seeing the solution. Without putting this formula, you should be able to put this formula first of all itself and try. Okay, that's always important. Try yourself. We'll go to the next question, question number 26. Read this question carefully. These are all very standard questions. You can see in many books the same questions. I try to read it and understand. Uniform shell explodes into 3 equal parts. Now these are all army military terms. Shell is exploding, and whenever the shell explodes, it's a big kind of a bomb, and it will explode and it will getting into many pieces. Now it is here telling out 3 equal parts. All the masses are equal. 2 of the parts fly off perpendicular to each other. So it is in right angles to each other, and as it goes with the velocity of 9 meter per second and 12 meter per second. Find the velocity of the third part. So you got 3 equal things. It is getting exploded. So one velocity is given, another velocity is given, third velocity is asked. And what happened to the masses? All the masses are equal. So that's what we get out of this. Pass this one, draw a diagram for yourself, and then you try yourself. If you have tried enough, now after some time, now you can start looking at the video what I have done to solve this question. So in this one, perpendicular to each other is something which is very important. And then it is also told one is 9 meter per second and next one is 12 meter per second. So it gives to me the mass, let mass of each shell be equal to m, and one shell is going with 9 meter per second, another shell is going in 12 meter per second. 2 shells are going in right angles to each other. Third shell should go here like this. It should actually go here like this. The velocity is question mark. And what is the shell which is going here? This mass is m, this is also m, and this is also m. All put together, all the 3 shells are having mass as m. Now we need to find out what is the velocity here. So before going to the velocity, first of all, it is also better to find out what kind of angle this will make it. 9 meter per second, 12 meter per second. These two will make an angle theta here, right? So this is making an angle theta means this also will be angle is theta because it's vertically opposite angles here. So you'll be able to figure out what could be the way it is. First of all, let us try to find out the answer of theta here. So velocity along y-axis is equal to 12 j cap, we can say, because it is j cap is this one. Velocity along x-axis, what is the value? 9 I cap meter per second. So the next thing is, what will be the tan theta is going to be equal to? So this one you can say Vy, this one is going to be Vx. Always tan theta is going to be equal to, so you can put a value here like this. So this 12 is going to be rooted here, and then base is already 9. This is 12, this is 9. So what happens here? Vy upon Vx is equal to Vy is going to be equal to 12 by 9. So theta is equal to 4 by 3. Theta is equal to tan inverse of 4 by 3. That will be the basic value you will get here. The next one is you need to find out the velocity. If theta is going to be equal to 4 by 3, you can find out the velocity also here. So how to find out the velocity? So the velocity will depend upon the resultant of momentum. So momentum is going to be equal to px square plus py square is equal to pz square. This is the momentum. So what is the momentum along x-axis? So it is going to be mass into velocity vx and then the whole square plus mass into vy the whole square mass into vz the whole square. Mass gets cancelled out, so vx square plus vy square is equal to vz square. So what is vz is equal to under root of vx square plus vy square. What is vx square? Vx square is velocity along x-axis, 9 square. What is vy square? The velocity along y-axis, 12 meter per second square. So it is 12 square under root 81 plus 144 under root is equal to under root of 225. So under root of 225, what is the answer here? V is going to be equal to 15 meter per second. So you get the value of Vz. This one will be 15 meter per second it will go. What did we do? We found the resultant of things. Now look at this one. This formula, how does it come? How did I put this formula? The momentum along mass into velocity. Mass into velocity of this one is momentum along x, this one px. Mass into velocity is py. So it is py. What is this resultant? It is px square plus py square. Is this resultant you will get here? Exactly opposite. This is the final momentum will be there. It is pz square. So what is this one is going to be equal to this whole thing. That's what I written here. Pz square is equal to px square plus py square. Because it is equal in opposite, it will be going here. So because of that reason, this formula is given and then you will be able to find out the answer. So it is 15 meter per second. And here also you can check the answers. Answer is 15 meter per second. Right? 15 meter per second. Then the theta is 127 is given here. So you got this value as tan theta is going to be equal to 4 by 3. Now this whole value, this whole thing, it is going to be 127 degrees. That's what given here. Because once you find this theta value using the table, then you can find out the rest of them also. 180 minus that angle, you will get 127 degrees actually you will get. Okay. So this is actually is going to be equal to 53 degrees you will get. Okay, we'll go to the next question now. Next question also, it is quite similar. It is again exploding into two parts. Look at this one. A body of mass 1 kg initially at rest. 1 kg is at rest. Look at this one. It is a bomb. 1 kg bomb is at rest. This body explodes and breaks into 3 fragments of masses in the ratio 1:1:3. The 2 fragments of equal masses fly off perpendicular to each other with a speed of 30 meters per second each. What is the velocity of the heavier fragment? Exactly the same question. Exactly the same question. 3 masses are there. Here 3 masses are mass m, here also m, here also m. But here 1:1:3. This is m, this is m, and this is going to be 3m. This is going to be equal to 3m will be there. That's what this question says. Right? And then if it is 3m is there, the next one is 2 fragments of the masses are flying off perpendicular to each other. The masses of equal m and m will fly off equal to each other, which is 30, which is of 30 meter per second. So it's going to have mass, going to be, the velocity is going to be same and it is going to be perpendicular. Find the velocity of the heavier one. You can easily find out. Try to just use the same method and find out this one. You will be able to do this question. Okay. Pause the video, draw the diagram and try yourself. So now after you have tried yourself, now you can see this one, how it is being solved, and compare your answer. Now mass and mass is there, same mass, and both of them are going perpendicular to each other. It is going with a speed of 30 meter per second, 30 meter per second, and 30 meter per second. So what we do is we try to take an projection here and write 30 theta here and see what will be the angle theta here. So velocity of shell along x-axis is equal to 30 meter per second. Velocity of shell along y-axis 30 meter per second. Right? Now tan theta, the angle is equal to Vy upon Vx. That is going to be equal to 30 upon 30 equal to 1. So theta is going to be equal to 45 degrees. So this theta is going to be equal to 45 degrees here. Once you get the 45 degrees, now you need to be a little careful about using the same kind of method or using a little different method. You can use the same method also. The px square plus py square is equal to pz square. You can use the same thing, also it's fine. But look at this one, the masses are different. 3m is there, mass is one is single m, another one is also there. I am going to follow a little different method from the previous one. Please follow this one. There is a slightly different method you are going to use so that you will be able to catch it up. Okay. Now 30 meter per second is there and mass. So here we are going to take this as m into v cos 45. So this is Vx. Mass into Vx, it is this one, this direction. Resolve into components. The resolved component is m into Vx times of cos 45. This is also going to be 45. So this 30 also will come here. This 30 of m into Vy, m into Vy also cos 45 will be there. These two are no more there. It is going to be in this direction. The direction is just similar. This direction of the component is equal to this one, right? So the momentum along line of action. What is the line of action? This is the line of action. So we are going to see 3m into v is going to be equal to m into vx cos 45 plus m into vy cos 45. That is momentum along the z-axis is equal to momentum along y-axis and momentum along z-axis, x-axis. So this is vx is equal to vy, vx equal to vy. Therefore, it's all over equal 2 times of m into v cos 45. That is going to be equal to 3mv. Mass and mass you can get cancelled out. This v is the question mark. This v is a small v. 2 into, what is the velocity? 30 into 1 by under root 2. And this 3 can come down. So v is going to be equal to 2 into 30 upon 3 under root 2. So this becomes here. So it is under root 10 under root 2. This is 14.14 meter per second. So that's going to be the formula. Now look at this. I have taken a different method to solve this. I did not take the previous one. I did not take the previous line like px square plus py square plus is equal to pz square. You can do this way also. Mass and mass is going to be equal to 3m will be there. So it's all going to be square. You can do that way also. 9 will be something will come and you can do that. And this is also another quite an important method. You can try to solve this way also. So please remember this. Now similarly that's one more question which is there. Now we did question number 27. We have already done question number 26. Now turn to page number 249 page number in your book and read this question. Question number 32. Similar type of question is there. There are 3 questions we are seeing quite similar. I'm just reading this one. An explosion blows a rock into 3 pieces. 2 pieces whose masses are 200 kg and 100 kg go off right angles to each other with a velocity 8 meter per second and 12 meter per second respectively. If the third piece flies off with a velocity of 25 meter per second, then calculate the mass of the piece. So all the 3 velocities are given. 12, 8 and 25 is given here. 25 is given here. You need to find out the mass of this one only. What is m? That's what it's asked. 100 and 200 is already given there. Look at this one. It's quite similar. So you can find out the resultant here and then go ahead. First of all, find out theta and then move ahead to finish this question. Please do this also. You can pause the video. You can try seeing this question. Write this question in the notebook, and then solve this question completely. It is also solved a little different. You can solve yourself also. Please do that. Question number 32 also, it follows now. Now we'll go back to that exercise question. The next exercise question is question number 28. So question number 28 we'll read. What does this one say? A projectile of mass 50 kg is shot vertically upwards with a velocity of 100 meter per second. After 5 seconds, the projectile explodes into 2 fragments, one of which mass 20 kg travels vertically upwards with a velocity of 150 meter per second. What will be the velocity of the other fragment at this moment? Now this is not 3 things, it is only 2. Projectile is going 50 meter per kg, it is shot vertically upwards with the velocity is given here. Initially mass and velocity is given here. 5 seconds later the projectile is exploding into 2 fragments, and one is going up and another one is going down. Pause the video, draw the diagram first of all. Quite important to draw it. Hope you would have drawn a diagram now. A mass of 50 kg is shot vertically upwards. 50 kg is shot vertically upwards with a speed of 100 meter per second. After 5 seconds, listen here, it goes up, takes a moment of 5 seconds. Now from here till this point here, this mass is here, what could have been the final this velocity? Initial velocity was 100 meter per second. After 5 seconds as it has gone up, what is the final velocity? We need to find out. This is u is equal to 100. What is the final velocity at this point after 5 seconds? It is going up for 5 seconds here. So v is equal to u plus at. What is v? You need to find out. What is u? 100 meter per second, and plus g, already it is given here as 9.8. So take 9.8 into t. Here it is minus 9.8 because it is going up, right? So it is going to be equal to, what's the value? It is 5 seconds is given here. It is 100 minus 9.8 into 5. So what is the answer you will get? It is 100 minus 49. So it's going to be equal to 51 meter per second you will get. That's the velocity. So here at this point of explosion, v is going to be equal to 51 meter per second. Now once it explodes, look at this one. It explodes into 2 divisions. One is 20 kg, it goes up with 150 meter per second, and 30 kg it comes straight downwards. So that's the only 2 segment it is given here. 20 kg travels vertically upwards with a velocity of 150 meter per second. And what will be the velocity of other segment at this moment? So the next one will straight away drop down with a velocity here. So now we got 3 things now, right? Now mass is 50, so capital M into V is equal to, now we need to see, small m 20 kg into that velocity plus 30 kg, maybe V1 and V2. You need to find out what is V2. So we'll have to substitute these values and get it. What is capital M? 50. 50 kg is this one. What is the final velocity? It is 51. 51, 20. And what is V1? V1 is 150. 150. And this is going to be a negative sign. It's going to be a negative sign because this is going to come to the opposite direction of this one. So 30 into V2. Every parameter you know. You need to find out the value here. So multiply these two things and put this one here and finally find out V2. Do this calculation. You will get the answer. The right exact answer you will get. Okay. So that way we can find out the value of V2. Similarly, this one you need to write according to law of conservation of what? Momentum. Final velocity, final momentum is equal to initial momentum of one body plus initial momentum of next body. Both the momentum put together. These two, all this one is initial momentum, this is a final momentum. So you get the final answer here like this. Looking at the question number 29, look at 29, there's a diagram also given here. Determine the magnitude and direction of the combined momentum of the moving spheres shown in the figure. So initially this is moving in the M1 is a sphere with mass M1, velocity is V1, M2 is a bigger mass going downwards with velocity V2. So this is in x-axis, this is in y-axis it's going. We need to find out the final combined momentum. So that same diagram is being drawn here. So this is going like this, and so if you see the body is going like this with the velocity V1, another body is going like this. It's a pretty bigger mass with the velocity V2. Now we need to find out the combined momentum. It will come somewhere like this. The combined momentum will come like this with the angle theta here. So what will be the final momentum you need to see? Okay. So how will you find out the combined momentum? So it should be mass into, it is going to be equal to P dash square is going to be equal to Px square plus Py square. So that's going to be the combined momentum. So m into mass into velocity here. So what is m1 into v1 square plus m into v2 square. So we need to find out this value and then get it. So what is m1? It is 2 kg. 2 into what is v1? 6 the whole square plus what is m2? m2 is 3 kg and v2 is 4 kg into 4 whole square. So what becomes here? This is 12 square plus 12 square. So it is 144 plus 144. So this is going to be equal to P is equal to, at the end of the time, what is P is going to be equal to? Under root of 144 plus 144. So it's going to be under 2 times of 12. 12 into under root 2. So you'll get the answer here. The momentum you will get here. So it is 17 kg meter per second. If you 12 under root 2, if you multiply 12 into 1.414, you will get 17. So what is the angle here? Angle is given here as 45 degrees. How to find out the angle here? Similarly, tan theta. Tan theta is going to be equal to Vy upon Vx. What is Vy? Vy is going to be V2 here. So that's going to be V2 is 4. And what is Vx? Vx is 6. That is tan theta. And you will get the answer here. So it's going to be, theta is going to be equal to 3 by 4. Tan inverse that theta is equal to 3 by 4 you will get. Right? So Vy upon Vx. What is Vy? Vy is, yeah, Vy is 4. Vy is this one. Right. Alright. Look at the next question. The velocities of two bodies, masses 5 kg and 10 kg, in x-axis and y-axis direction are 4 and 2 meter per second respectively. They collide and stick together. What is the final velocity? This question, these two questions are quite similar. So first one velocity is 5 and then the 5 kg mass is going in 4 meter per second, 10 kg mass is going in 2 meter per second, It's exactly the same situation, right? Exactly the same situation. One is going in x-axis, another going in y-axis. Finally, they collide each other and then get into a single body. We need to find out the final thing. This is exactly the same. So you can find out what could be the answer. So maybe the concept is little different, right? So one body is coming like this and another body is going like this, and they stick together and then it goes like this. So the first body is 5 kg and it is going in a speed of 4 meter per second. That is 4 meter per second V1. And next one is little bigger, 10 kg and going in a speed of 6 meter per second. 10 kg is going by 2 meter per second, 2 meter per second. Hits together and it has become a single big body and it is going in this direction. Once it is going in this direction, final value here, we need to find out what is the total one. It is going to be 15 kgs and we need to find it out. So the combination of both of them will give the final velocity here. So you can try to do this one, it will get the answer here. Now one last question we need to do from the exercise. With that we will close. Turn to page number 248. So 248 you take, and question number 31. Read this question. It's a very, very interesting question. A 20-gram bullet pierces through a plate of mass m1, which is of 1 kg, and then comes to rest inside the second plate of mass m2, which is equal to 2.98 kg. As shown in the figure, the first plate, it is already penetrating and going, and next the bullet is unable to go beyond this one and it gets stopped here. And this mass is 2.98, m2 is, and then the first one is only 1 kg, and the bullet is already given here. Now there are 2 times the collision is taking place. First time it is going and hitting here, and then it is again moving forward to the next one and it is getting here. Find the percentage loss in the initial velocity of the bullet when it is moving between m1 and m2. From m1 to m2 as it goes, what is the percentage loss? Because it is going in a very high speed and then it finishes all the velocity and it finally gets embedded here. Neglect the loss of material of the plates due to the action of the bullets. So we are not going to take the action reaction thing of this one. It is just going to see it is just penetrating and going and falling here. So if you look at this question here, the initial momentum, what is initial momentum? What has initial momentum? These two are then just static. The initial momentum is only mass of the shell and the mass of the velocity of the bullet. That is momentum. So it becomes 20 gram and the velocity. So you get here 20 gram and the velocity here. 20 gram and velocity. Look at this one. And then first plate is penetrating. First plate is mass is m1, it is 1 kg, and the velocity it is going to go as v2. And the next plate, the last plate is m, and velocity is v1, where it is going to go and hit this one and go. So the v of the first bullet speed of v, it reduces to v2, and the next one is again reduces to v1. So you get here 2 of them. So you are going to see the mass of the bullet and the velocity in which it is moving. So look at this one and try to find out how it is being designed, what is the way it is being designed. Now it is going together, the whole thing is now going to go together. So we find the first momentum and then second momentum for the first plate, and then second plate is there, and it is going to finally it is going to land up as a together velocity, and then go ahead and you can find out the value, right? So taking a little closer look on this, the first time is only the very first plate is being hit, and once it is being hit, what happens? And then the next time is the second plate is getting hit. So the bullet is going and passing by of the first plate, mass m1, and then it is immediately going ahead and then it passes by. It passes by and it goes. So initially it was v was there and mass is m, initial velocity of the bullet. Now it hits and then goes away. So as it hitting and going away, we are going to take the velocity as v1. With V1 it is going. Now don't only take the initial momentum of the bullet and final momentum of the bullet. It has also transferred some momentum to the plate. So let us consider V2 velocity, the plate moves. Right? This M1 and V2, and then M of the bullet and this one. So look at this one. Initial momentum is equal to final momentum. This is plate 1. What is initial momentum? M into V is equal to, what is final momentum? This bullet is going in a speed of M into V1 plus, it has already imparted some speed to the plate also. Plate is also moving. So it is going to be M1 into V2. This is equation number 1. What is initial velocity? This is going to be equal to 0.02 into V. It is going to be equal to, what is the mass of the bullet? 0.02 into V1 plus, what is the mass of the plate? This is the mass of the plate. It is going to be 1 kg into V2. We don't know. This is the one which is there. Right? Now, circulate 2. What happens? It goes here and it hits in M2. And as it hits M2, the bullet gets embedded here. So how do we do? So it is initial momentum M into V1. Initial momentum is M into V1 is going to be equal to M2 plus M. The M2 is this one, plus this is also going to be embedded here into the next value of V2. But look at this. It is told why I am putting V2 is, here also I have put V2, here also I have put V2, here also V2. It is saying that, the question says, it is found that the two plates initially at rest now move with equal velocities. What does equal velocity means? How do you describe equal velocity of the two plates? After hitting this one, it starts moving with velocity V2. After hitting this one also, it starts moving with velocity V2. Same velocity. This is also going in V2, this is also going in V2. So we have put the same V2 for the first equation here also. So mass is 0.02 into velocity V1 is the value which we will be getting here. The next one is mass is 2.98 plus 0.02, that is V2. So it is going to be 3 V2 and 0.02 V1. So that's the usual thing that is there. Now you can take this value and put it here. You can take this value and put it here, you will be able to get the V2 straight away. Right? Simple question, try to solve it. Finally they get the value of answers here. That is the way it is being solved. Okay children, thank you. Try to note down all these questions, do it carefully, and then we'll go to the next part in tomorrow's class. Thank you.